Hello students. Hello students. Today we'll try to understand number of ways of selecting r persons from n persons around a circular table such that no two persons are consecutive. Means on a circular table, we have some circular table. Total n persons are sitting. Out of those n persons, we have to select r persons in such a way that no two persons are consecutive. Okay, so what we will do is we'll try to understand the same question with a linear table, and we will convert that question into circular table. Okay, because understanding on a linear table is much easier. Okay, so I have taken some persons here, like on a linear scale, on a linear table, on a straight line I'm taking some n persons, x1, x2, x3, x4, so on up to some persons are there, xn minus 2, xn minus 1, xn. So total n persons are there. Out of these n persons, what I have to do, I have to select some r persons. Okay, consider this as the first person which I have selected, and a second person I have selected, and in between them also some persons I have selected. This is my rth person which I have selected. Okay, so here what I will do, I will define some variables. What are those variables? I will consider as this as p1. What is the meaning of p1? P1 is number of persons. P1 is number of persons before first person selection. Means, for example, if you will take for example, if you will take some five persons, if you will take p1, P2, P3, P4, P5. Five persons we have taken. Out of those five persons, if you want to select some three persons in such a way that if they are not consecutive, out of, for example, six persons, we have to select three persons in such a way that they are not consecutive. So I'm considering as P1. P1 stands for how many persons are there before before first person selection. Okay, P1 stands for how many persons are there before first person selection. P2 will stand for number of persons between first person and second person. Okay, means for example, this is a second person between first person and second person, so how many persons are there between them? Similarly, p3 stands for p3 stands for how many number of persons are there between second person and third person. So if we keep on doing, pr plus 1 we will get, है ना? What is pr plus 1? Number of persons after last person selection. After last person selection. So like if you select some person we have selected on the linear table, after that person some number of persons are there. That number of persons is given by pr plus 1. So these many persons are there after my rth person selection. Okay, so here what will happen, what is the relation between these variables? Let's try to understand them. Okay, so what will happen, like if we add all of them, p1 plus p2 plus p3 plus so on up to pr plus pr plus 1, this will be equal to how much? Total n persons are there. Out of those n persons, already we have selected r persons. So what we have to do, from total n persons we have to remove r persons. So I have written n minus r, because if we add all these persons, we have to get total number of persons as n minus r. Now, except these r persons, remaining all persons, if we add them, we have to get n minus r. Now, if no two persons has to be consecutive, then what is the condition? P1 has to be greater than or equal to 0. Why greater than or equal to 0? Because number of persons before first person selection can be 0 also. If P1 is equal to 0, the meaning is that first person selected is my x1 person, and p2 should be greater than or equal to 1, because between first person and second person at least we should have one person in between them. Similarly, p3 should also be greater than or equal to 1, because between second person and third person at least one person need to be there. So on up to p r plus 1 should be greater than or equal to 0. If this is equal to 0, then what do you get? Last person selected is my xn. If this is equal to 1, means last person, after last person, we have one person. The meaning is that the last person which is selected is xn minus 1. Okay, so we'll try to simplify this equation. How we can simplify this equation? Now here all variables are greater than or equal to 1 except the first one and the last one. Okay, so we will do one thing. For this equation I will add 1 for p1 and for pr plus 1. P1 plus 1 plus p2 plus p3 plus so on up to plus pr plus 1 plus 1 equal to n minus r plus 2. So here what will happen? This entire thing is greater than equal to 1. This is greater than equal to 1, greater than equal to 1, greater than equal to 1, greater than equal to 1. So if all variables are greater than equal to 1, so which result we have to apply? Number of natural number solution. Number of natural number solution. So what is the result for number of natural number solution? So it is n minus 1 cr minus 1. If we have an equation in this way, x1 plus x2 plus so on up to xr equal to n. If all these variables need to be greater than or equal to 1, all this variable needs to be greater than or equal to 1, then total number of ways it can be done is n minus 1 cr minus 1. So here n will be equal to n minus r plus 2 minus 1 c. Here total how many variables are there? R plus 1, r plus 1 minus 1. This is equal to n minus r plus 1 cr. So what is the result? Now what information this gives us? This gives us the information if n persons are there on a straight line. On a straight line, if n persons are there, out of those n persons, how many ways we can select r persons in such a way that no two persons are consecutive. So what we will do it now, we'll convert the question into circular table. So in case of circular table, what we have to do, we have to remove one case. Which case I have to remove? So if we consider circular table and linear table, so total number of ways of selection will remain same. Okay, but only one problem you'll get. That one problem is if है ना, if p1 and pr plus 1, if both are becoming equal to 0, in that case will become consecutive, because on a linear table है ना, p x1 is on one extremity, xn is on the other extremity. But if you take circular table, what will happen? X1 and xn, they will be together. So what should happen? Between the first person and last person, at least one person should be there in between. Okay, so if both will, what we will be doing, we'll be connecting x1 end to the x2 end. If you connect x1 end to x2 end, so in that case what will happen? Between them at least one person should be there. So from total cases, I will remove the case in which p1 and pr plus 1 both are equal to 0. So what you have to do? For circular table, how many ways we can do? Number of ways of selection that can be done on a circular table is equal to, so number of ways on in a linear table, or you can say straight line. From that one we have to remove the case in which p1 and pr plus 1 both are equal to 0. So this case we have to remove. So how many ways this can be done? If p1 and pr plus 1, if we will take both of them as equal to 0 in this equation, so what do you get, children? P2 plus P3 plus so on up to PR is equal to n minus r. Here P1 and PR plus 1 both I have taken equal to 0. Now we have the condition that P2 should be greater than or equal to 1. So here all variables are greater than or equal to 1. So we have to apply number of natural number solution. What is number of natural number solution? So previously I have told you that is n minus 1 c r minus 1. So here you will be getting n minus r minus 1 c. Total we have r minus 1. From r minus 1 we have to remove minus 1. Okay, So what is the total number of ways? So required number of ways. Required number of ways for circular table. Required number of ways for circular table is equal to total we had n minus r plus 1 cr. From that one, remove this case n minus r minus 1 cr minus 2. So this result will give us the total number of ways है ना, from n different objects from n persons sitting on a circular table, how many ways we can select r persons so that no two persons are consecutive. Okay, so this is the number of ways, children. So I hope you have understood. If any person is having anything doubt, just you can comment in the comment section. Okay, bye all of you.